organ without a body to build it in. We've been growing cells in the lab for decades, but they just sit around in flat layers or clumps. So how would you coax them to form a three-dimensional organ like a heart, with chambers, valves, and blood vessels? Maybe it's the same way you go from this to this. See, an organ is not unlike a building. It's a collection of parts that has to come together and work together. Think of a cinder block as a cell. The problem is, a block or a cell alone is not enough. To construct a building, you need to begin with an internal framework or scaffold to define the parts and hold them together. 30 years ago, transplant surgeon Jay Vacanti and chemical engineer Robert Langer realized that to build an organ, cells also need a framework, a scaffold to guide their growth. The challenge was to engineer scaffold materials living tissue could grow on.
So this is a material that we call biorubber.
Biorubber, and you use the prefix bio because whatever is the material it will take to flesh or living cells.
That's right.
So why does the cell even care?
Because a lot of things could be toxic to a cell, or the cell wouldn't like their surface and wouldn't be able to grow on it.
Picky cells.
Cells are picky, and some are more picky than others.
Cells are picky. If they are not grown on the right surface material and under the right conditions, then they will not function correctly. For years, scientists have been able to grow cells on flat surfaces, but have been unable to grow them in 3 dimensions. Much of the function of tissues is from its shape and how all the cells are joined together, like the heart. If it did not have all the chambers and valves, it would not be able to pump blood into. In other ways, cells are not picky. The body has cells called macrophages that will treat any implant as a hostile intruder. So even though an implant such as a knee replacement or total artificial heart intend to do good, the body treats them as it would an infection. There is no material known to man that if implanted in the body would not elicit a negative response. In the long term, implantation of this device will cause a foreign body response which leads to device weakening and ultimately device failure. This is an image of tissue section of the brain that had an implant. The intense green stainings are markers for the foreign body response. The red markers are for brain cells. The foreign body response isolated the area where the implant was from the brain cell. This is the same mechanism that the body uses to fight infections. The body will try and encapsulate any foreign material to block it from contact with the rest of the body. This shows more accumulation of foreign body cells around the site of an implant. Here is a cross-section of material that is surrounded by a layer of encapsulation. Glycogen Biosystems is a manufacturer of synthetic extracellular matrix components. Extracellular matrix is secreted by cells and surrounds them to provide physical support and to direct cell-to-cell signaling. A principal component of extracellular matrix is hyaluronic acid. Hyaluronic acid is a naturally existing high molecular weight polymer. It is also considered a carbohydrate and has a similar chemical structure to many sugars. There are other carbohydrates also located in the extracellular matrix, but the uniqueness of the hyaluronic acid is in its chemical structure. It has a specific arrangement of atoms that allow for chemical modifications. This understanding is what drove the formation of Glycogen Biosystems. It was formed under the direction of University of Utah medicinal chemistry professor Dr. Glenn Prestwich. By slightly modifying the chemical structure of hyaluronic acid with common laboratory techniques, it is converted from a long 2-dimensional polymer to 3-dimensional scaffold or matrix. This is not the same as the extracellular matrix, but its physical and chemical properties are similar enough that it can act as an artificial substitute. Hyaluronic acid products are more compatible with the body than other materials because it is something that our body makes naturally. Another advantage of hyaluronic acid matrices is that its ability to attach to cells. For decades, scientists have been able to grow cells on flat dishes in labs, but translating this into 3 dimensions has been complicated. Glycogen's products are moldable to specific 3-dimensional shapes and can incorporate cells within these shapes.